let's continue. So the first thing, as we have done, is try to simplify. So every single number that we have for addition and subtraction, the first thing is express in scientific notation. The numbers. Probably we need to mention that one step 0, see if we have the same units. So after that, simplify expressing in scientific notation every single part of the numbers. The next step, identify the magnitude order of the powers of 10. For the elements. To add or subtract. The magnitude order is basically the power. So as soon as we express in scientific notation, it's going to be very important. Pay attention to that power. Here. The reason is, so 2.1. If the difference of the absolute value of the magnitude orders is bigger than 3, the biggest the term with the biggest magnitude order will be approximately the answer. And we are going to think in one step 2. Let's go for step 2. If the difference of the absolute value of the magnitude orders is less or equal than 3, so let's call step 2.1 2.2.1. Then we choose the magnitude order that we want to keep. Okay. And we move our decimal point for the other term until we have the same magnitude order than the previous choose. Next, we make groups with units, magnitude order, and we can add or subtract the numbers. As you can see, this second step requires more steps. Let's try the first one, and let's make a graphic example. Move. Okay, suppose that we want to add something like this with a lot of imagination, please. Something like that. Something like that. With a lot of imagination, it's an elephant. And we want to add the mass of one elephant plus the mass, check, is the same mass of one little bug. So we are going to need a magnifying glass, and probably we are going to find something very, very small, like this. You are going to think, for example, whenever we think about the mass, one elephant, to give one approximation, is going to be approximately maybe 4 tons. And we are going to add the mass of one little bug. It could be, I don't know, like a half a gram. First, see that we have different units here, so we cannot add tons and grams. It doesn't have sense. But there is one relation between the metric ton to kilograms. So 1 ton is equal 1,000 kilograms. Here you can identify kilogram is the basic number. We can express like 1 times 10 to the 3 kilograms is 1 ton. So first we need to transform the units until we have what we are looking for. 4 tons are going to be 4, and we replace, instead of 1 ton, times 1 times 10 to the 3 kilograms, plus half a gram. Okay, I need to have the basic units for mass, that is the kilogram. You remember, we divide by 1 and we have 1 kilogram as 1,000 grams. That is one way. So at the end we have 4 times 1, 4 times 10 to the 3 kilograms, plus, if we use this, let me simplify, 0.5 times 1, keep kilogram is the only unit that has to keep the prefix, the unit for mass, and here we have 1 times 1,000, so I prefer instead to use 1,000, 10 to the 3. Let's keep simplifying, and we have 4 times 10 to the 3 kilograms, 1 and 1 is cancelled, and I have 0.5. See, I don't have a power of 10 here, so it's times 10 to the 0 minus 3 times 10 to the minus 3, and we have kilograms. Finally, we have the first unit. Next step, see if you have in scientific notation both. So 4 times 10 to the 3 kilogram is perfect, but this one we have one digit that is different of 1 or 9 to the left, so I need to move my decimal point to the right. So 5 times 10 to the negative 4 kilograms. Okay, let's continue in the problem. And we are going to see that we have the difference in magnitude order. Also, first we have scientific notation for both numbers and the same units. Maybe we can add. Let's pay attention to this. So the difference of the absolute value of the magnitude order. So the magnitude order of this is 3 minus, and this is minus 4. This bar represents the absolute value, and we have that is negative times negative positive, so 3 plus 4 equal 7. This number is bigger than 3, so we have to apply the first concept. If the difference of magnitude order is bigger than 3, the number with the biggest magnitude order, in this case 3, is going to be approximately the answer. So we can think that we have, this is approximately 4 times 10 to the 3 kilograms. It's not necessary to add nothing else. The reason, if you see your draw, think in this: how many bugs are on the skin of one elephant? It's full of bugs. If we add one more, it's not going to be a very big deal. If you want to have sense of this, okay, let's try to do directly. So 4 times 10 to the 3 kilograms, and following, I'm going to follow the second steps. You want to add this, so we need to express, I'm going to keep the biggest number, and I need to express this number in the magnitude times 10 to the 3. So using the inverse ruler of powers, 0, minus 1, minus 2, minus 3, and I am here right now in minus 4. So I need to move my decimal point 1, 2, 3, 4, 5, 6, 7 positions to the left. So 1, 2, 3, 4, 5, 4, 3, 2, 1, 0. Oh no, I need more zeros. 2, 3, 4, 5, 6, 7. Let me see. Is 4, 3, 2, 1, 0, 1, 2, 3. Okay. It's going to be here. So I'm going to have 3, 3, and 5 times 10 to the 3 kilograms. We can make the groups, numbers with number. Is the same magnitude order and the same units, times 10 to the 3 kilograms, so we don't need to repeat that. This is the kind of special orange or apple that we have, and the answer will be 4.0000005,000 kilograms. You see, it doesn't have sense to keep carrying all this, for the reason from the very beginning we were expressing that is the biggest magnitude order. It doesn't matter the number, it's going to be approximately the answer. We could, after 4 significant figures, and you see, it's going to be still the same answer. This is exactly how the first rule works. For this reason, we skip all these steps that are part of the second rule, and we go directly to one answer. It doesn't have sense. Let's try to use another example, what we have in astronomy, something important. For example, suppose that we want to add the mass of Earth. This symbol basically express Earth plus the mass of the Sun. This symbol, a circle with a dot, express the Sun. How much is that? First, let's try to think. The mass of Earth, my memory is good, is 5.9 times 10 to the 24 kilograms. And we have the mass of the Sun, that is 2 times 10 to the 30 kilograms. Let's see what happened. We have both units in scientific notation. We have the same units. So first, whenever we have addition or subtraction, we need to pay attention in the units. Okay, apparently it's the same mass. Now that we have in scientific notation, we need to pay attention to the magnitude orders, the powers that we have here. So the rule says if the absolute value between the absolute magnitude 1, 24 minus 30, y absolute value, this is the case, 25 minus 30 is minus 6. The absolute value is going to give me 6, and 6 is bigger than 3. According to the rule 2.1, if the difference of the magnitude order is bigger than 3, keep the biggest magnitude, the expression with the biggest magnitude order, in this case is the mass of the Sun, and that will be the answer. So the mass of air plus the mass of the Sun is approximately the mass of the Sun. Our planet is really insignificant, that is not really important for this. The solar system is 99% in average the solar system. The rest of the planets, including Jupiter, all those that exist, is basically insignificant with respect to the mass of the Sun. And we finish the problem. It's not necessary to keep going. If you want to solve it like we did before, okay, we need to express, and we are going to do more exercise like that. Let's try another example. Suppose that we have 6 times 10 to the 9 seconds minus 7 times 10 to the 8 seconds. So we have a subtraction. So the units, seconds and seconds. Let's see. Apparently, we can add something here. Let's see. Scientific notation, yes. Scientific notation, yes. So pay attention now to the magnitude order difference. So we have in this one 9, and the difference is A. So the difference is only 1. 1 is smaller than 3. So we have to apply the second criteria. The second criteria says choose one of your magnitude orders. I'm going to solve in both directions to demonstrate that it's the same. So right now I'm going to choose the 9th power. And the rule says express the second into the same. So my decimal point is here. So to be 9, I need to move my decimal point 1 position. It's done. Next step is make the groups. So these groups basically is going to make 6 minus 0.7, and the groups that we have right now with the power of 10 and the units times 10 to the 9 seconds. At the end, 6 minus 0.7 is going to be 5.3 times 10 to the 9 seconds, and we can express this one like 5.3 nanoseconds. Let's solve again the problem, but now instead to choose the magnitude order 9, I'm going to choose the magnitude order A. Let's take the original problem. We already saw the difference in magnitude order is 1. Now I'm going to keep this one. So I need to express this in the same. So if it's going to be negative, using the ruler of powers, it's going to be to the right. 60 times 10 to the 8 seconds minus 7 times 10 to the 8 seconds. We choose the groups, numbers with numbers. 60 minus 7, and all this is going to be the same. So times 10 to the 8 seconds is the special orange or apple, and we have that this is going to be 53 times 10 to the 8 seconds. We can keep oh, my mistake, I just watching that is not nano, it's in fact giga. my mistake for that. It's a positive, not negative. Okay, so playing with my decimal point, 5.3 times 10 to the 9 seconds, or 5.3 gigaseconds, the same answer. In both we obtain the same, so you need to be very careful and choose what is the magnitude order that you are going to keep and express the other at the same time. Okay, for another example, let's try something like this. Suppose that we have 7.3 times 10 to the 4 meters, and we have plus 1.2 meters. In this case, let's see, scientific notation. Yes, scientific notation, maybe we are missing times 10 to the 0. The same units, yes, so maybe we can add this. Let's see. Okay, when we don't have a power of 10, keep in mind that we have times 10 to the 0. So the one number 1 in this way is hidden there. So the difference is 4 minus 0 is 4, and 4 is bigger than 3. According to the first rule, 2.21, if the difference is bigger, of the magnitude orders is bigger than 3, the number with the biggest magnitude order will be approximately the answer. So we can say that this is approximately 7.3 times 10 to the 4 meters, and that's all. We don't need to do more. If you want to do all this, the next step, okay, see this 7, I'm going to choose 0, so it's 4 3 2 1 0. We know that this is 1, so we have 73,000 plus 1.2 meters and meters, so 73,000 plus 1.2 meter equal 73,000 1.2 meters. So you see, it doesn't have too much sense. So this is when we start to play to simplify, is 7.30012 times 10 0 1 2 3 4 meters, and we express usually